Alright, grade 12, so we are going to be going on to solution of triangles in 3 dimensions, but before I go into that, it's useful for you to have a look on page 183 in your textbooks, in your new textbooks, or your old ones. I'm sure it has it there. It shows you all the revision of the formulas for the sine rule, cosine rule, area rule from last year. I have also put up the notes for that, the grade 11 PowerPoints on the Google Classroom. And then it also talks about planes and lines, horizontal planes, vertical lines. This is on page 184, 185. It talks about vertical planes. And then it goes into looking at what these diagrams are going to be representing. So page 186 is really going to help you with that. Okay, it revises angle of elevation and depression also at the bottom there. And then we're going to be starting on this example. So I just want to explain what this example looks like using just physical paper, and then I will be going on to doing a video on my iPad, so not with the camera. So then you'll just have to watch the next video after this. Alright, so understand that in a question they will always talk about a vertical side. So often it will look like this. So something along these lines, where they'll match it up like this. Okay, and they'll talk about there's a vertical side or a vertical pole, but in reality what this actually is a three-dimensional situation. So where these yellow ones are actually sitting vertically upright to the pink, which would be the floor, representing the floor. So we talk about the pink being the horizontal plane and the yellow ones being in the vertical plane. Alright, and now the vertical ones are always at 90 degrees, because imagine having a pole or a wall, we build them 90 degrees to the floor, otherwise it's a skew pole or a skew wall. So we're always assuming that it's good workmanship, and so that we have nice 90 degree angles. So this angle here joining is not 90 degrees. It could be anything else. In the example that we're going to be going on to, this is 40, this is 60, and this one ends up being 80 degrees by angles of a triangle. So the vertical ones, okay, the top ones are at 90 degrees. They have a 90 degree angle, so you can use basic Pythag, normal trig, oh hell, another hour of algebra. But then your bottom one is a horizontal plane, a flat triangle, not a vertical one. And so the flat triangle, you're going to be using your sine rule and cosine rule and working them like that. So please, that when they picture them like that, it actually means that they are standing upright. You have to imagine that the upright ones are at 90 degrees. And so if we go back to page 187 in your textbooks, they will often shade the horizontal, the flat piece in, and then leave the vertical ones, the right angle ones, at 90 degrees. So in this example here, this is at 90, this is at 90. Now I know it doesn't look 90 degrees, but remember this is just a poorly drawn perspective. So if we were to draw it out, A, B, C would be at 90. A, C, D will be at 90, and those would be like my yellow ones, like that. And so they are drawn upright. Now imagine it's hard to draw it, you can't have it poking out the page, so these ones are sitting upright to the horizontal plane. So we draw them at 90. And then this one, the flat one, is the one that they join to. Alright, so that's what that picture is representing, is the pink and yellow pages here. Okay, it's almost like the yellow are walls upright against the floor. Okay, so the next video I'm going to show you, not on the camera but using my iPad, is how to solve this question, and then going on to the next type, which is on page 190 in your textbook, with the variable type with alphas and thetas. Alright, so please watch both videos.